Hi everybody. Here's your intro to Learning Target 9. Okay. We have just started Learning Target 9. Finishing balancing. So the goal of balancing is to make sure that we have the same number of atoms on each side. And so we just got done quizzing on that. And here's kind of remember how you do it. So if you had two hydrogen, two oxygen, one oxygen, I would need a 2 there. That also would need a 2 there. So what we're going to start talking about is what do these big numbers actually mean out front? And so the 2, what are these 1? What do these obscure numbers mean? Well, actually, what it means, these coefficients are an indication of how many moles. Okay? So you need 2 moles for every 1 mole of oxygen and you will make 2 moles of water. All right? So this is kind of what we call like our box recipe. If you were to say you wanted to double this recipe because you were making it, well, if you input 4 moles, you would get need 2 moles and you would get 4 moles out. And vice versa, if you were to you need to cut the recipe in half. Well, if you put 1 mole, well, then you would need 0.5 moles and then you would get 1 mole out. So this is kind of our standard recipe that we talked about, and that's why we balance. Moles is just a number of molecules, so we can manipulate that, and we'll eventually work towards that at the end. But the big numbers out front are called the coefficients, and these tell us how many moles of each compound are needed in a reaction. So in order to convert between moles of a substance, we need to use what we call the mole ratio. So the mole ratio we get these numbers from the coefficients out front. So the mole ratio between hydrogen, so all you have to do is look at the coefficients in front of hydrogen and H2O. So we would say, okay, hydrogen has a 2 in front, so it's 2. Water has a 2 in front, so it's a 2 to 2 ratio. What's the mole ratio between oxygen and water? Well, you got 1 mole of oxygen and you have 2 moles of water. And the mole ratio between O2 and H2, so you have 1 mole of O2 for every 2 moles of H2. Okay, so anytime they ask you for what the mole ratio is, basically anytime you need to find it, okay, the mole ratio, you just look for the big numbers out front after you have balanced it. And that's kind of the key thing. So we get them from the coefficients out front. All right, just go ahead and jot down these steps. Now we're gonna kind of talk about what happens when you don't have whole numbers and in the equation. Okay, so the first step is going to be similar to how we did mole conversions. The given number from the problem goes on the left. Okay, and so I'll use this example here from this equation down here. All right, so the question says how many moles of O2 can be produced by letting 12 moles of KClO3 react? So there's our balanced chemical equation with our coefficients, all right, our important numbers there. And the first step says this, the given number in the problem goes on the left. Well, the given number in the problem is 12 moles of KClO3. So you write 12 moles KClO3, okay? And then the other part of the question says how many moles of O2 can react? That's step 2. The unknown goes on the right. So we want to write moles of O2. Now, if you're savvy at math, you probably can apply the recipe to that without doing the steps, but all we care about is how you set it up right now. So if you have 12 moles of KClO3, how many moles of O2 can you do? And the next part says we're going to use our mole ratio to help us do that. So the first thing, I'm going to look at this map, okay? This is moles of A. Right here is the given number. So the given number is right there, okay? What you want to find goes on the right. That's moles of B, moles of O2, okay? Now we're going to apply this ratio in the middle here, and that's our bracket. So all you do is whatever number is out in front of A goes on the bottom. So what number is out in front of A? 2. 2 moles of KClO3 goes on the bottom. What's out in front of B, which is O2? 3. 3 moles of O2. Okay, so how you set that up is just using this map, and you can use brackets, or like if you're in a Lentis class, you use this train track. So if you were in Lentis class, you're going to use it like this, 12, and then it's going to be 12 moles of KClO3. It's going to be 3 moles of O2 and 2 moles of KClO3. Okay. So then how you punch in your calculator is 12 parenthesis 3 divided by 2. And I believe that should be 20, bad math, 12, 3 divided by 2, 18. So 18 moles of O2 can be made from that equation. So that's the gist of it. We'll do some more practice. We just want you to get down the steps and at least hear some of the definitions, things with it.